All right, today we're going to be exploring three things: direct and indirect variation and something called circles. Everybody knows what a circle is, right? Oh, piece of cake, piece of cake. Okay, so here's direct variation. It's an easy topic. Easy topic. Now, we're going to talk about a vocab word. Vocab word. Anybody know what the word constant means in math? Justin? Yeah, it doesn't change. Just so you know, in the word in math, the word constant is going to refer to a number. Give me a number. Good. Those are all constants. Give me a number nobody else would think of. Okay, you get the point. Anytime you see the word constant from here on out, it means a number. So just out of curiosity, if you plugged a number into this equation over here, what kind of shape, what kind of picture would you get if you drew it on a piece of paper? What's that a picture of? Yeah, exactly. This is a picture of a line. So let's write that down. Right? Let me see. So I'm just curious. That's real cool. So we're going to try and answer a word problem about direct variation. In the word problem, it says very specifically this, varies directly. That means you got to use the equation above. Profit P, inventory I. How do you do something like this? Any ideas? Julius? Okay, yeah, actually, direct variation applies to proportions. You can use proportions with it. Uh, can I show you the way that I've been taught and I normally use it? Let's see. Step one. Step one. So it's like if P equals 100 when I is 20, find P when I is 50. Well, the first thing we got to do is we have to find K. And by that I mean that we got to sub out y and x for this equation, and we're going to sub in p and I. Okay, so this equation, when you sub them out, is p equals k times I, right? Profit varies directly with inventory. So as inventory grows, so does profit. Yeah. And it doesn't matter where you sub them in. If it mattered where you sub them in, it would say that in the problem. Okay, so this is going to be 100 equals k times what? 20. Whoops. Divide both sides by 20. Turns out k is 5. All right. Now what do you do from here? Then you plug it back into the second part of the problem, which says find out how much p is when I is 50. So step 2. We're going to solve this in there. So p equals, k is 5, I is 50, so p is equal to 250. Whoops. So if you plug that into your calculator, what kind of shape do you think you're going to get? Go. Well, check it out. The x is in the bottom. Remember we talked about k. Constant of proportionality, that's just what it is for inverse variation. It's the same as basically the idea of the constant of variation for the other problem. A constant is a constant. Give me any number you want. Give me a number nobody else would think of. Let's go with 3. It's easier to enter. Now let's take a look at what this picture looks like in your calculator, right? So everybody, hit the y equals and hit 3 divided by x. That's it. Looks weird. Looks real weird, right? Let's draw that on our paper so that we can remember it. Let's draw that on our paper so that we can remember, because this is a question that comes up on your Regents exam. They basically show you a whole bunch of pictures of graphs, and they say, which one represents inverse variation? Anybody know what that's called in math? Starts with an H. Y. P. Nope. It's called a hyperbola. It's a hyperbola. Yep. Whenever you see a graph like that, we've got a whole lot of inverse variation going on. So just be able to pick it out. Now I have a word problem for you. Whoops. Sorry about that. Sorry about that. And let's see what you can do. Julius, I wish we had you on videotape. Yeah, we're going to set this up just like the other one. We're going to sub out y and x, and we're going to sub in h and t. And for this problem, it doesn't matter because it didn't specify where h and t had to be solved. At the end of the day, as Julius put it, we're going to be cross multiplying, and we're going to get the same answer. So k ends up equaling 130, and we're done. It's an easy idea. Easy idea. Oh, all right. So we tried to find the center of the circle. The center of the circle is at 2, -3. It's got to match with the formula, and if it doesn't match, like in this particular case, there's a plus sign, and over here there was a minus. Then you just take the opposite of the number. What's the radius of this guy? Yeah, the radius is 5. Very nice, right? Because this number over here is the radius squared. Perfect. One more problem to go. One more problem to go, and then we're out of this joint. Okay, so what's the equation of a circle with 0, 0 as the center, and 3, 4, and 3, 4 on it? Now, Michael Dorman, a very, very smart person, genius, figured out this particular way to solve the problem. And I'm going to present it to you because all my other classes think it requires no work and it's so easy. And then I'm going to show you the other way that I always learned it. So he said, well, here's the equation for a circle. And he had it memorized since he was in geometry. And he said, well, the only thing we don't know right now is the what. The only thing we don't know is the radius, and watch what happens. We could just plug the rest of the stuff in. So do you know what h is? H is 0. What's x? X is 3. Right? H and k are always the center. That never changes. X and y are the other coordinate that you're given. Okay? And so what's y in this particular case? 4. And what's k? And so check this out. It filled everything out. Genius, right? He's a very smart man. (25) equals r squared. 5 equals r. Also take notice of the way that I organize my work. What does it look like? A pyramid, it funnels down. Oh, it's beautiful when things look like that. Love that. You could do that. This is the hardest circle problem given on your Regents exam. And like, what do you think? Is that hard? Now we got to figure out a way to write our answer. So our final answer, and then I'm going to show you the other way that I did it, and then we're done for today. Final answer is that, let me show you the 3 ways that you could write our answer. You could say that this is x minus 0 squared plus y minus 0 squared equals 25. You could say that this is also, or you could say that this is x minus 0 squared plus y minus 0 squared equals 5 squared. That's also okay. Furthermore, you could write it one last way that you might see it presented, and that's without the zeros put in there, because it's pretty obvious that when you subtract 0 from something, you get the same thing. The very last way we're going to try and take a look at this problem is graphically. Graphically. Who is the most famous mathematician you know of? Good. I mean, Einstein is my favorite. He's my hero. I have a trading card on my desk of Einstein. Okay. One day I too hope, if I were that lucky, I could get a trading card of me made one day. But everybody knows of a guy named Pythagoras, right? So let me plot down the two coordinates we got right now. We got the center right here. The center's right there. And so then we're going to plot the other point. 1, 2, 3, and we're going to 1, 2, 3, 4. Bless you. 3 this way, 4 that way. And so check this out. Now, Pythagoras is so famous because, and he didn't even make this up, he stole it from a bunch of people. He figured out the universal way to calculate distance. Check it out. We went 3 units this way. We went 4 units that way. What did it form? And of this triangle, since this is the center, right? Guess what this is? That's the radius of our circle. Oh! Oh! It is the hypotenuse, you're right. Oh snap. Yeah. Ooh, Alicia, breaking out the content knowledge. Pythagorean triples. Ooh. Same thing. Same thing. So are we good? Does anybody not understand what went down today?